Welcome everybody. My name is Bernhard Rümpfel. I'm an application engineer and trainer at Softing Automotive. Today I would like to talk about the challenges of diagnostic testing, the OTX ISO standard, and our product, Softing OTX Studio. First, what are the challenges of diagnostic testing? Modern vehicles include a high number of electronic control units, the ECUs. And for each ECU there is a variety of variants that describe the software versions. They all need to be tested. The ECU software itself is subjected to increasing complexity. It can also happen that diagnostic functions are distributed to several electronic control units. And above all, we can have repeating diagnostic tasks that are time and cost intensive. From that, we can conclude that test automation is essential. It's not possible anymore to carry out each diagnostic task manually. Here we see a sketch of an automated diagnostic test. What are the major tasks of such automated scripts? We can have a combination of several diagnostic services. Of course, we benefit from that because we don't have to search for these services inside the database. We can have automated analysis of response parameters and results. And at the end, we can create a diagnostic report file that summarizes our findings. There are many programming languages available, but typically they require deeper knowledge and are controlled by the IT industry. So the best solution for diagnostic scripts is the OTX programming language. We have an algorithm, and with the ISO standard 13209 we can realize our diagnostic test. The full name of OTX is Open Test Sequence Exchange Format. The scripts consist of elements coming from two different groups. The so-called OTX core that provides assignments, variable types like integer, string or boolean. We can define conditions with if-else statements. We can insert loops like for and while. And even parallel programming is possible. We can add parallel lanes to our diagnostic script. The other group is called OTX standard extensions. One example for the extensions is diagnostic communication. With this extension, we can create a communication channel to an electronic control unit. Or we can get the full list of all available communication channels. The Flash extension gives us OTX elements that allow us to create a Flash job, Flash session, or to read out the list of all valid Flash sessions. The extension HMI provides a set of predefined dialogues that help us to create a user interface. Of course, there are many more elements. With the help of these elements, we can realize a variety of diagnostic tasks in OTX. Let me give you more complex examples. One example is parallel Flash programming, where we start the software update for several electronic control units at the same time. The user interface provides start buttons and progress bars. We can even embed National Instruments I/O cards to our OTX scripts. We can send a measurement device service that controls the voltage, for example, of a device. Guided fault analysis is a complex dialogue that guides the technician to the root cause of the problem, with the help of pictures and instructions. Now, let me outline the benefits of the OTX standard. We benefit from a simplified, though fully capable programming language, and we get a simple exchange of diagnostic sequences. And another aspect is the exclusive supervision of the OTX standard by the car industry. All changes remain in the hands of the car industry and not the IT industry. Now, let's focus on our product, Softing OTX Studio, which is optimized for the specification phase. We can switch to specification mode, where we place boxes and where we can write normal text, so no programming skills are necessary in this case. The real programming happens in the implementation mode. And we can execute our diagnostic scripts with the help of a standardized OTX runtime. OTX Studio includes several editors. The most important editor is the so-called script editor, where we program line by line. Additionally, we can use the GUI editor for the creation of graphical user interfaces. Here we select an application frame and we can place widgets like buttons, like checkboxes, and so on. For validation tests, we can use the test case editor. It provides a list of the most important procedures, like checking the valid and invalid service IDs. In this video, the focus will be on the script editor. Here we see a short diagnostic script where we open a communication channel to an engine control module. We send the read service for the engine speed. We store the result in a local variable, and we display the engine speed in a confirm dialog. The question is, how can we create such a script in OTX Studio? Just 4 steps are necessary. We select the ECO variant, then we select the diagnostic service to read the engine speed, we store the result in a local variable, and we insert a confirm dialog. Of course, much more is happening in the background, which is done by Softing OTX Studio for you. Now, let's see OTX Studio in action. Here we see Softing OTX Studio. In the OTX project Test Automation, we navigate to the diagnostic database. First, we select the ECO variant of the engine control module. Then we select the read service for the engine speed. The diagnostic service can be added to the script editor by drag and drop or double click. Please be aware that this single action generates 3 elements in the script editor: the creation of the communication channel to the ECO variant, the execution of the diagnostic read service, and the closing of the communication channel. The response parameter for the engine speed can be stored in a variable RPM, rotations per minute. Softing OTX Studio assigns a new variable automatically. In order to display the result for the engine speed, we can use the OTX extension HMI, which provides all kinds of dialogues. In our example, we are going to use the so-called confirm dialog. It can be added to the script editor by drag and drop or double click. The script editor allows us to configure the title and the message of the confirm dialog. Since our variable RPM is an integer value, we have to convert it with the OTX expression to string. Now, Let's execute our OTX script. The confirm dialog shows the result for the engine speed. Let's assume we want to analyze the result for the engine speed. We can use the if statement. It can be added to the script editor by drag and drop or by using the keyboard. With Shift space, we add a new line and then we type if. Of course, the if statement requires a condition, which is described by a Boolean term. The else statement can be added to define the logical opposite. Existing OTX elements can be repositioned by drag and drop. Let's add another confirm dialog using the keyboard, which generates a warning if the engine speed is too low. The confirm dialog allows us to change the message type, which gives us a different icon. When we now execute the OTX script, we get a warning if the engine speed is too low. Let's summarize our findings. We talked about the challenges of diagnostic testing, including a high number of electronic control units, increasing complexity of the ECU software, and repeating diagnostic tasks. The solution is test automation with the OTX ISO standard 13209, which gives us a simplified language and exchange. We get an exclusive supervision by the car industry and not the IT industry. The realization of the standard is our product Softing OTX Studio, including also the script editor. And the use cases of automated diagnostic tests are combination of several diagnostic services, automated analysis of response parameters and results, and the creation of a diagnostic report file. If you are interested in OTX, check out our website, leave a comment below, or contact me directly. My name is Bernhard Rümpfel, and I'm looking forward to seeing you in my next video.